All right, this is for response part C. All right, so this says the function g is given by g of x equals the definite integral from -2 to x of f of t dt. All right, find the absolute maximum value of g on the interval -2 to 5. Justify your answer. All right, so first thing we want to realize is if this is g of x, all right, I need to know, according to the second fundamental theorem of calculus, that g prime of x is found by taking x and plugging it in for t, and then multiplying by the derivative of x, which is just 1. So g prime of x is just f of x. All right, and so that's really good to know because this is actually just a graph of g prime. All right, so now let's think about g then, if this is your sign analysis of g prime. All right, so what do you know? All right, you know that g prime is positive here, so it's g is increasing. Then it's negative here, so g is decreasing. Then it's positive everywhere all the way to the end, so g is increasing once again. All right, so if we look at kind of just a quick little like sign analysis chart, all right, we have a 0 at -1, right? And we're endpoint of -2. We have a 0 at positive 1/2, and then we have a 0 at 5. And that's it. All right. And so we know that it's 0 here, 0 here, 0 here at that endpoint. All right. And so it's positive, then negative, then positive. All right. So what does that mean? That means that G would be increasing, then decreasing, then increasing. All right. So G starts at some endpoint. It increases, then decreases, then increases, right? Now, we're only really looking at -1 and 5 as being the possible locations of our maximum. And why is that? Well, remember that -1 is a location of an absolute or of a local maximum, and 5 is an endpoint, but we're increasing up to that endpoint, so that is potentially a maximum as well, right? So we really just want to compare those two, all right? But if we just think about, okay, we're starting at -2. So what is g of -2? So g of -2 would be the integral from -2 to -2 of f of t dt, all right? Which, well, of course, that's 0. All right, so then what about at -1? G of -1 would be the integral from -2 to -1 of f of t dt, right? And so what would that be? Well, that's the area under the curve from -2, excuse me, sorry, from -2 to -1, right? Which we figured out earlier, that's just 1/2. All right, now what about at 1/2, g of 1/2? Now we know that that's not the maximum, but it could be a minimum, and so we would want to think about that. -2 up to 1/2 of f of t dt. All right, well, what is that? Well, that's going to be the amount of this area, okay, minus the amount of this area, right? And so that's 1/2. That was 3/4, right? So 1/2 minus 3/4 is going to give us -1/4, right? All right. And then lastly, the other value is g of 5, right? Which is the endpoint on the other side. All right. So what is the endpoint on the other side? Well, that's what we um, figured out. If you go all the way back to the other value, that would be the integral from -2 to 5, right? That was part A, basically, that we used to figure that out, right? And that was this 11 minus 9 pi over 4, I believe, right? And so g of 5 is the integral from f of, oops, sorry about that, all right? Uh, the integral from -2 to 5 of f of t dt, which is 11 minus 9 fourths pi. All right, and so now you're really just looking at 1/2 and 11 minus 9 fourths pi. So now you got to figure out, well, is this thing bigger than 1/2? All right. Well, what would this be? 9 pi, right? Which would be, well, 9 times 3.14, right? So 9 times a number slightly bigger than 3. So that'd be like 27 something, right? Minus, or 27 or greater than 27, right? But if you went all the way up to, let's say it was even 4, 9 times 4 would be 36, right? And 36 divided by 4, right? That would be 9. So 11 minus 9 would be 2. So this thing has to be greater than 2 because pi is not even close to 4. So the maximum value is actually 11 minus 9 pi over 4. So that is our answer.